Hi, everyone. Welcome. This is the Node Operator Community Call, episode number 12 already. Izzy is unfortunately not available today, so I will be hosting the call. I will be your MC. We got a short agenda, but it's action-packed. They're very cool items, to be honest. They're really cool. We're going to start with a short overview of the CSM proposal. Now, this has already caused quite a stir in the ecosystem, so it'll be cool to see what that's all about. We've got more of an intermission. We got our Q3 stats that we're going to be sharing, the Phantom update. We've got ETH Zurich did a really nice research. They presented it a few months ago already, but we asked them to present it on this community call, and we're very happy that they accepted and they want to share their report with us. It's about decentralization. Also really cool. I like this one as well. We have the initiative that was awarded a Lego grant recently. It's called DUC, a Decentralized Utilizations of Configuration and Knowledge. You can see some work went into getting that acronym put together, but we're going to see an update, or actually an introduction of that particular initiative. It's really cool. It's about utilizing all the extreme amounts of knowledge and experience that we have available to us in a very productive and open source way. But Julian will be talking about that. First up, we have an overview of the CSM proposal. Dimitri is going to present that. Are you ready, Dimitri? And share your screen whenever you are. Good to go.
Yep, here I am. So let's kick it off. So, hello there, Node Operators Community Call listeners. Today, we will talk about the recently proposed Lido Community Staking module, also known as CSM. My name is Dimitri, but as you probably noticed, I'm not the Dimitri that you're looking for. Yep, I'm Dmitry Chernuhin, and I'm also a community staking team contributor. I think the best way to start our journey toward the CSM is by Lido's mission: to make staking simple, secure, and decentralized. Among a wide variety of ways leading to this mission lies one that me and other Lido contributors find extremely valuable. It is community stakers' participation in the Lido protocol. By community stakers, we mean independent individuals or groups running validators while being aligned with Ethereum goals and values, whose primary motivation is not financial. So, introducing Lido Community Staking Module, a staking router module made for community stakers by community stakers and staking fans, with main goal to make Lido validator set permissionless and accessible for everyone. We want to make CSM the best permissionless option for community stakers. During the design stage, we focused on 3 key values. First, reduce barriers to entry, since Ethereum solo staking today is a challenging task, both from an economical and technical perspective. Next, improve Ethereum's resilience by bringing new independent operators to the Ethereum network. And make solo validation more profitable, because at the end of the day, we all need to pay bills. Now let's take a closer look at the main CSM features, starting with design. Without any doubt, permissionless entry is the main CSM design feature. Anyone will be able to join Lido validator set with no strings attached. But is it enough to offer permissionless entry to make solo staking simple? Of course not. Most community stakers already use amazing tools for Ethereum validator setup preparation. So why should we ask them to use another one? Instead, we aim to offer integration with as many well-known software and hardware providers as possible. Now let's talk about bond. In CSM, bond will be a node operator property. Hence, the more validators the node operator has, the more coverage available for a single validator incident. With that in mind, we believe the bond requirements can be reduced for the second and further validators. This feature is usually referred to as a non-linear bond. And since node operators in CSM have to log the bond to upload new validator keys, it seems reasonable to allocate stake to these keys in the same or a similar order as the operators upload them. 5/9 efficiency can hardly make Ethereum more resilient compared to 97 or even 95%. That's why rewards will be distributed between CSM operators using Performance Oracle using a threshold algorithm. Node operators showing performance above the threshold will get socialized rewards in this frame, while the others won't get rewards at all. This approach will provide a leeway for small performance outages while ensuring that low performance remains economically unfeasible. Now it's time to move on to the CSM features that I find to be really cool. And the first one is a low bond. It's hard to comment much on it. The bond requirement will be as low as possible, given the latest state of Ethereum and market conditions. Right now, the 4ETH option seems to be safe, with the possibility of moving to the 2ETH options once the EAP 7002 release date becomes clear. Do you remember the first point in the Lido mission? Right, make staking simple. Operator UX should definitely be simple and easy. With CSM, it will look like the following 3 steps. Prepare validation setup, submit deposit data and bond, and finally, run validator and claim rewards. That's it. UX simplification will not only make it easier to use CSM, but also make it cheaper. With fewer operations required, gas fees will hardly exceed typical interaction with the average DeFi application, making it affordable for anyone. Ethereum's researchers do their best to overcome the extremely volatile nature of MEV. While MEV burn seems like a good solution, it is relatively far from implementation. How Lido can help community stakers here? You guessed it, by offering MEV smoothing across the whole Lido validator set. Any MEV extracted by Lido validators will be evenly distributed across all the staking modules, including CSM. Now the coolest feature. There will be no additional tokens required as a bond. Only ETH. We do believe protocols should not add new variables to the Ethereum staking equation if they can. Hence, from the very first day of CSM, only ETH or STETH will be required as a bond to create CSM validators. Well, it looks like we're done with the features. What's next? Here is the approximate timeline of the CSM development in the case of DAO approval. We hope to have CSM live on the testnet in the middle of the next year and on the mainnet by the end of the 2024. And like Steve Jobs used to say, one more thing. CSM team wants to say huge thanks to Florian from HomeNode and the whole eBanker team for their help and support in the production of the first ever Lido boxes. They look awesome, right? Well, now that you know about CSM, do not hesitate to learn even more and to express your opinion in the comments on the proposal you will find in this QR. Thank you so much.
Thank you, Dimitri. That was great. Seeing if there's any questions so far. I think it's good that you share the QR code. People are definitely invited to share their opinion. They haven't restrained from doing so yet, and we definitely welcome that. Really looking forward to the entire ecosystem for their opinions on this thing. If no questions, then bear with me as I share my screen with you guys. Go on. There we go. A short update from our side. the validator and node operator metrics Q3 is out. It's already Q4, of course, but we usually spend a lot of time working on the data submitted by all the node operators in the curated set. We aggregate those to a nice dashboard. We do this for Ethereum on Lido on Ethereum as well as Lido on Polygon. You can find them both under the QR code. There's a whole bunch of stats we show, particularly this quarter and going forward. We'll be showing a more detailed breakdown about infra type, so bare metal or public cloud, dedicated, co-located stuff like that, as well as the reliance on service providers. If there's a service provider active for a particular node operator, we all note them down, and we see how that service provider is distributed or used across the entire set. Also exciting to see just the smallest dent in the geographical distribution, the smallest dent in improvement, as we have onboarded new node operators in Latin America and Africa, and they just caught the tail of Q3, so you can't see them in the stats, and it really triggers or signifies the start of a broader distribution globally. So Q4 will actually be more exciting because we'll see them running significant amounts of keys in those two new continents, and really happy to see that start. That was a direct result of Wave 5 onboarding, so yeah, we'll be keeping an eye on that. So please scan the QR code, and for now, I'd like to give the word to share my screen, multitask. Sorry about that. I'd like to give the word to Dominic Grandjean from ETH Zurich. He's author and co-author, I should say, of a very deep diving research into participation and decentralization of the consensus layer. They do a really nice comparison of what they call an optimistic view and a pessimistic view of Lido stake share. And from like we saw the report, and we like the first thing we said is we have to invite these people to the node operator community call, because this is a really good breakdown of what's going on, and really excited to have them now. We had to skip a few calls because we couldn't find a time where they had availability, but we're glad they made it in the end. So Dominic, if you're ready, please kick it off.
Okay. Thanks for the invitation. Can you see my screen?
Yes, sir, we can.
Perfect. So welcome, and I would say let's have a look what those proposals and attestations on-chain can actually tell us about the participation and decentralization of the Ethereum beacon chain. And I would say we jump right in. I want to give you a bit of a background. Roughly 1 year ago, I started my master thesis at ETH Zurich, and during which I looked at DDoS attacks on Ethereum validators. More specifically, I tried to find instances where validators or validator entities try to attack other validator entities to basically maximize their profits. And while doing so, we had to do a lot of entity clustering, and we mainly used the rated.network labeling set, as well as labels from Etherscan and Beacon Chain, and some of our own labels we have. And this then led us basically to looking at decentralization of the Beacon Chain itself, and the participation and all that around, including consensus clients. And there are two papers, two different versions of those papers. If you have seen one, then you probably have seen the first one. And I'm now mainly talking about the second one, where we introduced or look at LSTs and the optimistic and pessimistic viewpoint. So I would say, let's start on the basics. Let's start with proposals. And we collected all the proposals since Genesis all the way up to May 15th, 2023. And what we can see in this plot is we have the successful proposals, missed proposals, and also the orphan blocks. in front of us here, it is important to note that this graph on the y-axis starts at 90%, so it looks worse than it actually is. And what we can see is that larger upgrades like the Altair, Bellatrix, and Merge, they show us that there is actually an increase in misproposals, probably because people don't upgrade their nodes or there are some small issues, which is to be expected. We can also see an incident, for example here, incident A, where you had a bug in the Prism client, which then resulted in more missed proposals. Similarly with B, where we had an incident with one of the Lido Node operators, and then also a Prism bug, which worsened the situation. And then more recently, the attack on MEV Boost and also the bugs in Prism and Teku that then resulted in the finality issues that we had a few months ago. They are also visible here. Also notable is that the orphaned blocks actually almost disappeared since the Altair upgrade and then came back after the merge and are slowly rising there in the back. We can do the exact same thing for attestations. And in this case, it looks a bit more choppy, but it's very similar. We don't really see the impact of those, for example, instance A and also B. There's not really something we can see, but we do see that the upgrades again result in more missed attestations than usual. Also, since the merge, we have a little bit of a heightened amount of missed attestations, which is likely due to more stuff going on. And don't forget, we also have more and more validators that the network needs to handle. We also looked a little bit at slashings. And we have the separate slashings, so for slashing for attestations and for proposals. And in this plot, we also show the delay, basically the delay that is between the slashable offense and the slashing itself. And this is, be aware, a log scale on the y-axis here. And we have some outliers on the top, but usually the slashing occurs quite quickly after the offense. We also had a quick look at the consensus client distribution, and this is actually looking quite good. So we see that, Prism, at the time dominant consensus layer client, really lost some of its market share, and we can even see a little bit of Lodestar up in the top right corner, and that will hopefully also grow a little bit in the coming years. We again see this incident B quite significantly here, where we had the incident with Lido, and this is due to some of those Prism clients just not being there, and therefore just quickly this loss of market share, which after the fix just went right back up there. Okay, let's talk a bit more about the clustering of validators into entities. And as I said, we used some data sets there and did that clustering. And in this plot, we see the top 70 of those entities that are actually staking on the beacon chain. And we colored the top 5 entities here. And what we definitely see is that over time, the dominant Coinbase, Kraken, and Binance, the dominant centralized staking providers, really had lost market share. That got gobbled up by Lido. And this trend is definitely clear here, and we will see how that continues. And now that Lido is at the 33% mark, if there is somebody else that tries to take away that market share, or if Lido is actually just continuing as it is right now. We looked at the success rates of entities. So we said, okay, let's look at larger versus smaller entities. Do we see any differences here for the success rate? So having how many successful proposals or attestations do they have if we compare them? And for us, the threshold here in this plot is 1,000 validators per entity. So a large entity seems to have a better success rate, especially for attestations. which does make sense because usually they also have better hardware and they have some fail-safe mechanisms in place, hopefully. And this is noticeable here for the attestations. However, both for proposals and attestations, we see for large and small entities that, it is above 98%, so very high for both of them. But larger entities do make more in this case, and that's something we can see. Also interesting when we look at the proposals, and at the proposals where you have proposal success rate equals 0, we do have some validators from larger entities that are down there. And this is basically due to some validators. And again, this is log scale, so it is too large in perspective. This is due to validators that belong to large validator entity groups, that their first proposal is basically a miss. And in that case, they can stay there for months until they get their second chance. And this is why we have a heightened amount there. And if they, as a second proposal, succeed, then they go all the way to 50%. And this is why we have another small peak there. And then they move up the ladder as they go. So clustering validators into entities for centralized staking providers is actually fairly easy. So for Coinbase, you just take those addresses and you say that's one entity, that makes sense, and that's simple. However, for LSTs, it's much more difficult. And what we did is we wanted to define boundaries, an upper and basically a lower bound, where we look from the vantage point of the Ethereum blockchain. And we define an optimistic and a pessimistic view. So what we say that at the time, when we basically finished the data set, Lido had 30 operators. So in the optimistic view, we say, okay, all the LSTs, they are separate, or in the case of Lido, we have those separate operators, so 30 separate operators. And in that case, we say, okay, they are really separate, so they're using different hardware, they're using different, let's say, contracts. They don't use the same governance. And on the other hand, the other extreme would really be, okay, it's all the same governance, it's the same contracts below. They don't want to collude. No, this is the opposite. They could collude if they wanted to, right? And in the optimistic case, really, they couldn't even collude even if they wanted. And we do this with all the LSTs, so also Rocket Pool and Swell. And what we then can do is we can basically go through history and see, okay, what actually are those boundaries? And we started with proposal sequences. And we can clearly see that if we have first the optimistic case, in that case, Lido is in 30 operators. In that case, those 6, 7, and 8 blocks in a row, they're mainly generated by Kraken and Coinbase, which are still large in that case. However, when we go into the pessimistic case, then all the chances above, so 9, 10, 11, all the way up to 13 blocks in a row, this is then basically something that Lido can use to their advantage. And why is this important? This is important because this allows for multi-block MEV, which, if it is exploited, can hurt the network as a whole. So this should not be underestimated. We then also looked at some coefficients. We start with the Gini coefficient. The Gini coefficient basically gives us a value for inequality. And this value is between 0 and 1. With 0 being we have minimum inequality and 1 being maximum inequality. And we compare that to the proof of work era. And what we do note is that we have basically, since the merge, those two numbers diverge and then flattening out over time. And we don't really see a big difference between the optimistic and pessimistic vantage point in this plot here. We also looked at the Nakamoto coefficient. again for optimistic and pessimistic viewpoints, and then for the 33 and 50% of market share for one, or basically for the market shares where we have significant problems or changes for the network. And in this case, if we look at the optimistic viewpoint and be aware, those are boundaries. So if you say, okay, let's look at the 33% mark, so at the red and the dark blue lines, the reality is somewhere in between those lines. And depending on your viewpoint or the viewpoint how you analyze the network, you will be somewhere in between those lines. And that gives us between 10 at the time, 10 and 2 entities that are enough to basically reach those 33%. The proof of work numbers are also in there. They're a bit hidden and as a green number. And what we can see is that if we compare the pessimistic viewpoint and the merge numbers, they are actually very similar right now. And only in the optimistic view, they really then diverge. We also looked at the Herfindahl-Hirschman index. So this index is used in economics to show concentration in a special field. And it again is from 0 to 1. And what it tells us is in close to 0, we basically have many companies that have the same market share. And if we go closer to 1, we have in the end only one big company that has all the market share. And this is what we can see. And in this case, we have a big separation of optimistic and pessimistic viewpoints, and they really diverge almost since the beginning. And in the pessimistic point, we are on the same levels as the proof of work before the merge. And in this case, we do see a large divergence. Important to note is that the HHI and also the Gini coefficient, they have not been made for blockchains. So it is a bit tough to say what does this actually mean now. But this just gives a reference to what people already know and have been studying for a while. And last but not least, we also looked at Lido in particular, because Lido has such a big impact on the staking landscape and on Ethereum itself. So we looked a bit at the ecosystem, so at staked ETH and the LDO holders, as well as the 30 entities. So basically, how much do the 30 entities inside of Lido have compared to each other? And we again look at the HHI. What we do see is that over time, the HHI is reduced, and at the moment we are maybe a bit plateauing. But that's definitely a good sign. Overall, if we look at the value of the HHI, this value is higher than the general network, which also does make sense because it's a subset of the whole, but that is definitely notable. Okay, and that brings us already to the end. Thanks a lot, and thanks again for the invitation. If you have any questions, remarks, suggestions, don't hesitate and contact us.
Yeah, Dominic, that was great. Thanks. And we discussed this a bit up front because I was obviously interested in like what defines for you. Well, I'll ask it differently. Why did you come up with this optimistic and pessimistic viewpoint, like this range that you set up because you changed it at one point?
Exactly. So the thing is, it is very difficult to make it fair for all the LSTs in that case, because we have, if you compare Rocket Pool and Lido, they really have different approaches, and it is hard to compare them. So we said, okay, let's make some boundaries, and then it is a next feed to basically really categorize where exactly you want to place it. And this also depends on your own viewpoint. And we didn't want to pick a side basically, but we wanted to show, okay, those are the ranges, and that's what we have basically. And it is really difficult to come up with really clear definitions of how decentralized or centralized something really is. And I think many people can argue about that for a long time.
Yeah, we only have an hour, so we're not going to do that.
Yeah.
Let's see. No, let's not go into that. I wanted to ask another thing. Maybe you mentioned it, but the proposal, the continuous proposal sequence, what's the significance of that?
So that's probably the first plot that we've seen, right? Let's just quickly go back. You mean this here, right?
One after this. This is the data.
So
it said continuous proposal sequence.
Okay, the sequences. Oh, sorry, yeah. Okay, yeah. So basically, what this allows you, if you are a single entity, and you know in advance which blocks that you will basically control. You see that in advance. You see that 2 epochs in advance if you want to. So you can, let's say, you know you will control the next 5 blocks. So you can basically make a plan and say, okay, in an extreme case, it might be advantageous for you that in the first few blocks that you have, you don't even include any transactions, but you wait and wait all the way to the end in order to maximize MEV. That might be the most profitable trade for you. In that case, you have empty blocks and transactions not going through. That this is bad for the network. On the other hand, you could say, okay, maybe you see you have a 5 consecutive blocks in a row, and then you have one block that is controlled by somebody else, and then again you would have 5 blocks in a row. And it would be really nice to then also get this one in the middle, so then you control all 11 blocks in a row. So this gives you an incentive to maybe attack this validator that is in the middle, and to basically ensure that he's not proposing. So you again have this entire row of 11 blocks. And you can basically, you have a lot of power over a long time and you control this block space, right? And this can be valuable for you and also bad for the network if this is being exploited.
That makes sense. We have a question in the chat from Jan. He asked what the numbers associated with the specific sequence lengths mean. Now that they're occurrences, I understand, but maybe you could use this also as an opportunity to explain, like, what's the difference, for example, at a sequence length of 6 between the optimistic 79 and the pessimistic 1336. How does that work?
Yes, so basically the sequence length is really the number of consecutive blocks that a validator entity has, right? So in the example before, 5 would be the sequence length. So this entity controls 5 blocks in a row and knows that in advance. And in this case, if you look at the optimistic row, in that case, we had 498 of those occurrences where one entity had this sequence length, like this exact length, not longer. And this is basically, how this is by many entities. So this could be Coinbase and then 200 by Kraken, and this is just added up, basically. And then the same for the pessimistic viewpoint, but again, in this case, we combine Lido as one entity, and this is then what we get.
Okay, that's very interesting. Did you look at any other ways? Because this would require collusion in the pessimistic version, and optimistic, there's no collusion at all between, well, in this case, Lido node operators. Are there any other like attack vectors or attack angles that you researched?
In this paper, not really. I looked at the DDoS attack scenario that I just explained earlier in my master thesis. And that is definitely an interesting thing. But it is also difficult to prove that something like this is done, right? With the MEV, and if you don't include transactions in certain blocks, that's definitely obvious. And the community will notice that. But there are ways to do it, and it is difficult to detect as a community that this is really happening.
Yeah, this is the proposal sequence, the occurrence of the actual sequence of 5 blocks in a row by a particular operator. It's not obviously not the case that this is exported at this time. Okay, that's great. Thanks very much. Looking at the time, we have to continue. So I just want to thank you very much for coming on and presenting this. Really cool. Julian is up next from Lionscraft, going to introduce the brand new Duck knowledge base proposal.
Perfect. Yes. I hope you can hear and see me.
Loud and clear.
Awesome. Hi, everybody. Julian, my name. I'm happy to introduce Duck to you and walk you through it. It's not the animal duck, but maybe a sort of different animal we're tackling here. And we essentially want to create a framework for node operation excellence. And for those of you who haven't heard of Duck yet, I want to give you a bit of background on what we try to tackle with Duck. Essentially, we want to find a way in order to boost the node operation excellence across the whole Ethereum ecosystem and try to find ways of collecting the knowledge that is already out there in you guys, in the node operators and kind of beyond that. And we want to kind of create something that collect that and create something that bolsters kind of the strength and robustness of Ethereum overall. And by saying that, I would like to introduce Duck to you. I hope, of course, majority of you guys have seen the Lido forum proposal already. For those of you who haven't, DUC stands for Distributed Utilization of Configurations and Knowledge. So it was a bit of a work to come up with this acronym, but we made it. And behind DUC are essentially 3 components. So we intend to create the first component, which is the risk framework. So that should cover kind of relevant risks for node operations, what kind of group them, how severe them are they, and give you some context around those risks. And based on that risk that we identify, we want to essentially define mitigations and controls in order to address those risks, and create like a controls catalog and mitigation strategies, and give you also a bit more resources in that regards. The third component that we want to create is a communication toolkit that should be kind of a collection of best practices around external communication. So how to engage with the community, and what ways, what channels, and what do I need to do in terms of incident reporting? What are just general best practices around community engagement? And with those 3 components, we essentially want to create this DUC framework, or the DUC initiative, and maybe kind of talking also about who actually is behind DUC. So who's helping DUC to take off. We of course have super happy to be bootstrapped by Lido and all the contributors that I will get to in a second. On top of that, we kind of have 4 teams that all contribute to those three components of DUC, and that kind of are experts in their respective field. We have risk experts with Constant and Chain Proof who will contribute to the risk framework, with Hibernative and CoGuard, as well as to the mitigations and controls library. And we have in the team to kind of set up the foundation, or also Blockscape and Kiln on board, so that we can kind of come up with a hopefully solid foundation of those 3 components. And kind of looking at these partners, which yeah, I'm super excited about to kind of join forces and create these frameworks. We have actually already started, and we are very, very happy that we can now finally kick things off. In November, we got the approval for the proposal. We kind of set the whole team up. We also created a Git book, which I will get to after that, and which contains essentially all the relevant information for you in case you want to get more details on what's going on and what's the status of the project. And basically also kicked off the risk framework work already. And if we look ahead for over the next 4 months, we plan to kind of create the risk framework and mitigations controls library in blue and green until end of January, and basically create a first initial draft that should contain risks and kind of the categories, mitigations for the respective risks. And this initial drafts, this will be then shared with all the contributors from the Lido operator community, which we really hope that we get as much support as possible. So this will be the part where we rely on your input, where we rely on your expertise, what you can kind of give us or support us on the journey essentially, and give us feedback regarding what we created there in order to make it better and kind of cover more design choices, more options, more mitigation strategies, methodologies. And based on that, we will kind of create the final version, the alpha release, in end of March. And on top of those two components, we have the communication toolkit, which will then start in January because it's independent of the other two. So looking at the timeline, this is where we plan, or how we plan to roll it all out, and essentially also get the your input from the node operator community at the stage where we have kind of a rough structure and foundation that you can take a look at and hopefully help us make it even better. If we step a bit back and look at Duck from a more broader sense, I would just like to give a bit of information around that as well. So we are now at this public call for participation and basically trying to breed these components for the alpha release. And after that, we plan essentially to open up the knowledge base more and get more operators and more knowledge inside, and also kind of find a way to make that a sustainable and liquid knowledge base, so that it basically stays up to date, that this will be a source where kind of which is being updated and represents kind of the current state of the art around best practices. So this is in a nutshell where we try to go, and in the long run and the short run, or for the alpha release. And I mentioned that we already started kind of the reach out to our contributors or to you guys, and we are currently super excited that we have already eight contributors on board that support us on creating and reviewing contents that we come up with. And I really invite you to scan the left QR code, and if you're a node operator and also would be willing to support us on that journey, and just get in touch with us, fill out the form. We are happy to get in touch with you and also work together with you on this initiative. If you need more infos around kind of the whole setup, what we plan to do, what's the timeline, what's the status, I'm inviting you to scan the right code. That should lead you to the Git book that we will constantly update based on what's going on, where you will see the current version of the the risk framework, of the controls, and also the communication toolkit. And yeah, I would just generally apply or try to, would be very, very happy if you guys would get in touch and join the flight of Duck. So that being said, thank you very much, and happy to reach out, and yeah, looking forward to getting this on the road.
Thanks, Julian. Thank you so much. That we've been talking about this proposal you shared for, I think, a few months already, and the difficult part for us, anyway, is to, like, we're partnered with a large amount of node operators, and some of these node operators just have incredible knowledge about staking as a whole. So, crypto manufacturer there, we have dev teams, client dev teams, large staking providers, and we're really looking for a way to, like, get these people to share their knowledge with the broader community, not just the Lido Node Operator set, but this is an open source initiative, right? So
exactly,
with
yes.
the ecosystem as a whole. And the difficult part was like just having them share their knowledge without coming up with some normative way of staking. Like, this is how staking should be done. Like, each of these node operators are experts in their own way, and I'm really happy this is this proposal as it is now is it's kicking off. I was looking at the selection of volunteer node operators. They have a lot of experience. How do you feel about this? These volunteers?
I mean, for us, it's super important to kind of capture the diversity that is out there already, right? And I mean, looking at the list, we also have one question around the size of the operator, and it's actually quite nicely distributed. So we have kind of bigger operators, some medium, and some small. So I'm really curious, and I think that's a good thing that we have this mix in the contributor part, but also of course really would be of course better to get more insights from different operators on top of that. But from what we have now, it's already kind of nice to have them on board. But of course, anybody interested to reach out, please do so.
Yeah, it's definitely a wish to squeeze every drop of knowledge and experience from other node operators to share it overall, because the community, the ecosystem can only get better. You mentioned this is the alpha stage. I know nothing is set in stone, but do you have an idea about the beta and the gamma and the
I mean, for now, we don't have like super concrete super concrete details around that. We will really, we're trying to get as much out of the alpha as possible, and trying to make it as broad as possible and helpful as possible. So after that, kind of we need to see how far we get, and from there we hope to make it even broader beyond Lido, or with operators beyond there, to kind of open that up even more to the community. And as Sven, you mentioned, so this will all be open source, right? So we will publish, or as you saw the link on the Gitbook, this is kind of the public documentation for it. So it should actually be for the community, with the support of the community, and this is what we try to work towards.
That's awesome. If people have questions about this, they can contact you. Well, you mentioned your Telegram there.
Exactly.
Is there any communication possibility via the Gitbook? Is there a link there for people to provide input?
On Gitbook, I can add that maybe as well, but there are all the links towards the also Telegram group that I created for the every operator or all interested people in this initiative. So just check out the Gitbook. Maybe I can just share it again in case you missed the QR code, and there you should find all the information around that.
Yeah, that's great. Izzy is mentioning in the YouTube chat that be great to see small and large node operators contribute to this. So definitely looking forward to this. Really happy about this initiative.
Awesome. Me too.
If there are no other questions, yeah, I think it's time to wrap up already. I would like to thank, first of all, our presenters. So Dimitri from the CSM team, Dominic was here from ETH Zurich, and of course, we just saw Julian from Lionscraft sharing the doc proposal. So thanks to those presenters, really amazing presentations. We'll be sharing them for people interested. And for now, I'd like to thank all our viewers or listeners and remind you that the next node operator call number 13 should be up at the end of December. So stay tuned for that. Agenda is not set yet, but we have a bunch of different options, and we're going to make it action-packed as usual. Hopefully Izzy is better than back in the saddle at the MC controls. And for now, have a good evening and see you next time.